Imagine you are standing outside on a clear night. No city lights, no clouds, just you and the sky. The same sky humans have stared into for 10,000 years, unchanged, eternal, safe. You find the constellation Vela, low on the horizon, ancient and quiet. You've seen it 100 times. And then, without warning, without any warning at all, a new star appears. Brighter than the moon, bright enough to cast shadows, bright enough to read by, bright enough that you instinctively raise your hand to shield your eyes. It wasn't there a second ago, and somewhere deep in your chest, before your brain has even formed the thought, you know, something just died, something enormous, and it died looking straight at you. For billions of years, two dead stars have been circling each other in the dark. Neutron stars, the crushed remnants of suns that burned out long before our world even existed. Each one is roughly the mass of our sun, compressed into a sphere the size of a city. Manhattan-sized, city block-sized, and yet carrying more weight than 1,000,000 Earths packed together. From a distance they would look almost peaceful, two dim embers spinning slowly around each other, a cosmic waltz, a death dance that has been going on since before the dinosaurs walked this planet. They are 1,000 light years away. That sounds safe. That sounds like a number that should make you feel better. It doesn't. Because for the last 10 million years, those two stars have been spiraling inward, inch by inch, orbit by orbit, each revolution pulling them a fraction closer, gravity drinking in their momentum, the space between them shrinking so slowly that nothing alive could ever notice. But something is wrong. They are close now, very close. And the universe is about to collect what it is owed. In the final second before impact, the two neutron stars are moving at nearly half the speed of light. Half the speed of light. The number doesn't even feel real. In the time it takes you to blink, they cross a distance that would take a passenger jet 6 hours to fly. The gravitational waves they produce in those final moments ripple outward like a shockwave through a pond, stretching and squeezing the fabric of space itself. Not through space. Space itself. The distance between atoms in your body grows and shrinks by a fraction smaller than a proton as those waves wash through Earth. And you feel nothing. You can feel nothing. The instrument humanity built to detect this, LIGO, a laser tunnel 4 kilometers long, barely registers a shift 1/10,000th the diameter of a proton. And that's just the warning. Then they touch. In an event called a kilonova, two city-sized objects containing the mass of two suns collide at relativistic speeds. The explosion is 500 times brighter than an entire galaxy of stars. For a few seconds, this single event outshines every star in the Milky Way combined. 1,000 light years away, and it is the brightest thing in your night sky. Brighter than Venus, brighter than the full moon. A new sun, burning cold and blue-white on the horizon. But here's the problem. Light is not the only thing travelling towards you right now. Before the light even reaches Earth, something else does. Neutrinos, ghostly, nearly massless particles, pour outward from the collision at almost the speed of light, a fraction faster through the cosmos than photons because they don't interact with the debris clouds surrounding the explosion. They pass through the planet without stopping. They pass through you without stopping. Trillions of them. Every second, punching clean through your body like you don't exist. You will never feel it. But it gets worse. Because trailing behind the light, building quietly in the void, is the gamma ray burst. Neutron star mergers are one of the only known sources of long gamma-ray bursts. Focused, narrowly beamed jets of radiation so energetic they make nuclear weapons look like candles. When two neutron stars collide, the resulting jet can travel for billions of light years without losing coherence, burning through space like a scalpel. 1,000 light years is not far, not for a gamma-ray burst. If that jet is pointed at Earth, even slightly, even grazed, the ozone layer doesn't just weaken, it dissolves in hours. The ultraviolet radiation from our own sun, which that ozone layer currently blocks almost entirely, floods the surface of the planet unfiltered. Nothing with eyes survives unchanged. Photosynthesis collapses, the base of every food chain on Earth erased. Scientists believe this may have already happened to us. The Ordovician mass extinction, 450 million years ago, 85% of all species gone, may have been a gamma-ray burst from a dying star. Not an asteroid, not a volcano, a beam of light from something that died 1,000 light years away, pointed by pure accident directly at our world. And this is where things change. Here is something that should make you feel small in a completely different way. The collision is not just destruction. In the unimaginable heat and pressure of two neutron stars merging, temperatures of billions of degrees, densities beyond anything that exists anywhere else in the universe, something is being created. Heavy elements, the kind that cannot form inside a normal star. Gold, platinum, uranium, lead, every piece of gold that has ever existed on this planet, every ring, every crown, every coin, was forged in an event exactly like the one happening 1,000 light years away right now. The atoms in your jewelry crossed interstellar space as the debris of a kilonova that exploded before our solar system was born, drifted through the galaxy for billions of years, and collapsed into the cloud of dust that eventually became Earth. You are made of stardust, but your gold is made of something far more violent than a star. But that's not even the worst part. We detected a neutron star merger for the first time in 2017, an event called GW170817, picked up simultaneously by LIGO's gravitational wave detectors in 70 observatories around the world. We watched it across the entire electromagnetic spectrum. It was one of the most observed events in the history of astronomy, and what came back unsettled physicists. The gamma-ray burst arrived 1.7 seconds after the gravitational waves. Gravity and light should travel at the same speed. The fact that they didn't by 1.7 seconds across 130 million light years was within the margin of our best theories, barely. But the afterglow behaved strangely. The jet structure didn't match any clean model. The heavy element yield was higher than expected. We do not fully understand what happened. We have the data. We have the theories. They don't quite fit. The universe produced an event so extreme that our best physics, the physics that built the atomic bomb and sent probes to the edge of the solar system, gave us the right answer only approximately. 1,000 light years. Close enough to see with the naked eye. Far enough that we think we are safe. We think. That light in the sky, the new star, the one bright enough to cast your shadow across the grass, will fade over the coming weeks. It will dim from blue to gold to red to nothing as the cloud of freshly forged heavy elements expands outward into the void. In 10,000 years it will be invisible. In 100,000 it will be a faint nebula. In 1,000,000 it will be gone entirely. the debris scattered so thin across space that nothing will mark where two dead stars ended. And somewhere in that debris cloud, drifting outward at a fraction of the speed of light, too diffuse to ever collect, too scattered to ever be touched, will be enough gold to fill 1,000 Earths. It will drift for billions of years, through the dark between galaxies, through the slow collapse of the next generation of stars, and maybe, just maybe, some of it will fall into a young solar system, around a young star, onto a young planet, and a creature will find it, and call it precious, and never wonder where it came from. The universe does not care that we are here. It was building and destroying things like this long before life learned to be afraid of the dark. The kilonova at the edge of Vela was not a warning. It was not meant for us. It simply happened, vast and indifferent and incomprehensibly beautiful. And we were lucky enough to be standing in the right place, at the right time, to see it. Or unlucky. It's hard to know which, from this distance.